Good day, everyone. Welcome to Math Sudan. Here's a powerful question we are going to be treating today: underlying integral. The question says, evaluate I integral of x raised to the power of 2 plus 2y dx plus xy dy from 0, comma 0 to b, comma 1, comma 4 along the curve y equals to 4x squared. So how do we approach this? The first thing that we are going to do is take note that this is a line integral, right? So we draw our graph to represent the question given to us. So the first thing we are going to do is to draw your graph to locate those points. These are the 2 points. We have 0, comma 0, which is from the origin, which is 0, comma 0 at point O. Then we are locating 1, comma 4. This is the x-axis and y-axis. 1, comma 4. We are moving all the way to 1 in the x-axis and all the way to 4 in the y-axis, right? So this is be our point where they both meet. So this side will be 1, comma 4. So then I say along the curve y equals to 4x squared. And you know, for a curve, for a square graph, is going to be a curve. So this is y is equals to 4x squared, right? Y is equals to 4x squared. So let's say this is the point. So we are evaluating I integral from what? X squared plus 2y dx plus xy dy. So for us to approach this, we are going to use the properties of line integral, which states that integral of p dx plus q dy is an integral of the line. So we are asked to find this integral. If you are to evaluate it, the value for p is x squared plus 2y. Then the value for q is x, y, the y. So we have to find the x, the y. But before we find the x, the y, we have to substitute the value for y. And the value for y is 4x squared. So we have p is equals to what? 4x squared plus 2, open bracket, 4x squared, the x. Then we have p is equals to x squared plus 8x squared dx, right? So then for q, we have q is equals to x, open bracket, 4x squared, the y, then q will be equals to 4s cubed, the y. But yet we are still seeing the value for y. So we have to take the integral for the line, for the value for the curve. We have y is equals to 4s squared. The y will now be equals to, if you differentiate this, you have 8x dx. So you substitute this y into this equation, you have q is equals to 4s cubed, open bracket, 8x dx. 4 times 8 will give you what? 32x raised to the power of 4 dx. So you add the equation together using the properties of line integral, which states that the integral from 0 to 1 along the x-axis, that will be 0 to 1 along the x-axis, which is p is what? X squared plus 8x squared dx plus the value for q will be 32x raised to the power of 4 dx, right? So that will be integral from 0 to 1. S squared plus 8x squared will give you 9x squared dx plus 32x for dx, right? So this is still equivalent to integral from 0 to 1, 9x squared plus 32x for dx. So you are integrating with respect to x. If you integrate 9x squared, you have what? You have 9x cubed over 3, right? Plus 32x to the power of 5 over 5, 0 to 1. So you substitute the value for 1, which is the boundary. So having the boundary, you have 3 here, 1, 3 here, 3. So you have 3x cubed plus 32 over 5x raised to the power of 5. So you substitute value for 1 and 0. You know, if you substitute value for 0, everything will give you 0. So imputing 1, you have 3 open brackets 1 cube plus 32 over 5 raised to the power of what? 5. So you have 3 plus 32 over 5, right? So the integral will now be equals to, take the LCM, which is 15. 15 plus 32 over 5. So I will be equals to what? Which is 47 over 5. So 47 divided by 5 will give you 9 number, 45, which is 3 over 5. Then this is the value for the line integral when you are giving the value for I. Thank you very much. Thanks for watching. Follow for more videos. Bye.